Okay. So, गुड इवनिंग फ्रेंड, वेलकम टू अवर चैनल एग्जामपुर आईएएस इंग्लिश मीडियम। आप सभी का हमारे परिवार एग्जामपुर में स्वागत है। सो टुडे वी आर गोइंग टू डिस्कस द मोस्ट इंपॉर्टेंट करंट अफेयर्स फ्रॉम द पर्सपेक्टिव ऑफ मेन इटसेल्फ। दिस इज आवर फोर्थ सेशन। ऑलरेडी वी हैव डिस्कस्ड अ लॉट ऑफ थिंग। वी आर नॉट टेकिंग दोस टॉपिक that is from the perspective of prelims. Rather, we are taking those topics that is important from the mains itself, and we are trying to discuss all the dimension that is important for the prelims itself. So kindly join the session. Kindly join our session. Please join our session. Am I audible? Acha, extremely sorry. Now, is it audible? Mridul, now is it audible? Okay, sorry, extremely sorry. So the first topic, let us start from the beginning itself. So we are going to start. The first topic is your welcome dental world. How are you? Good evening. What's your original name? Please do let me know. So this is our first topic we are going to discuss regarding the space topic. This topic was in news because Indian Space Research Organization, they have started working on the NETRO project. Basically, when you talk about the NETRO project, this is a project that has been initiated by the ISRO for the purpose of monitoring and controlling the space debris. For the purpose of monitoring and controlling space debris. So ISRO has started installing or deploying, you can say, new radars and optical telescope for the purpose of monitoring. So when we start space debris, first of all, we should know what is space debris. What is space debris? So this is the Earth. This is your Earth. This is your Earth. Okay. This is your Earth. And apart from that, this is your low Earth orbit. This is your low Earth orbit. This is your low Earth orbit. And this is your polar orbit. This is your polar orbit. This is your polar orbit. Now this is your polar orbit. Polar orbit. You might be knowing that the satellites, maximum satellites, welcome Gobind. Maximum satellites are parked in the low Earth orbit. Okay. Maximum, you might be knowing that maximum satellites jo hote, they are parked in the low Earth orbit. Maximum satellites are parked in the low Earth orbit. Okay. Maximum satellites are parked in the, apart from that, the satellites are parked in the polar orbit too. Polar orbit also, the satellites are parked. Now, suppose these are the satellites. Now, suppose you have parked certain satellite in the year 2000. Suppose this satellite is parked in 2000. 2000, okay, 2000 year. Now it's your 2022. Generally, it is seen that the life of the satellite depends upon the life of the payload. Because what is the purpose of the satellite? The satellite purpose is to monitor. Either to monitor the topography or to monitor the resources. Okay, but the payload that is being installed in the satellite is having certain lifetime. 15 साल 20 साल, they are having the lifetime. So generally the payload जो होता है उनकी lifetime कितनी है? 15 years. So after 15 years, this satellite is of no use. This satellite is of no use. This satellite no use. This satellite no use. This satellite no use. 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 So these satellites, these satellites are of no use. Now can you think what is the purpose of staying? What is the purpose of the satellite is still being there in the low Earth orbit and polar orbit? So if the satellite is of no use, if the satellite is of no use, but still the satellite is still parked in the low Earth orbit, polar Earth orbit or any other orbit, then it is called space debris. Is it clear? Is it clear? And the other orbit is this is the orbit. This orbit is called geostationary or geosynchronous orbit. This orbit is called geostationary, geostationary and geosynchronous orbit. This orbit is called geostationary or geosynchronous orbit. Now you might be knowing we are having certain launching vehicle, just like we are having a small satellite launching vehicle, polar satellite launching vehicle, and apart from that we are having geosynchronous launching vehicle. Generally it is seen that if the satellite is of heavier nature, then generally we employ geosynchronous launching vehicle for the purpose of parking the satellite in the geosynchronous orbit. So the cost of launching or the cost of placing the satellite in the geosynchronous orbit is very costly. So generally not much satellites are being parked in the geosynchronous orbit. So much of the satellite density it is there in the low Earth orbit, polar orbit or any other orbit. So the satellite that is being parked for the purpose of monitoring something, but after certain time when its payloads are not working, but still the satellite is there in the orbit, then it is called space debris. Okay, so this is your artificial space debris. Apart from that, we are having the meteoroids, that is the natural space debris. Is it clear? Okay, any doubt? Okay, see, you can see in 1957 this was the condition. In 1957 this was the condition. In 1992, because of the development, because of the technical advancement, this is the condition, and 2015 this is the condition. You can see the Earth is completely covered with satellites. and 80% of the more than 85% of the satellite is of no use, but still it is there. That means what? It's a debris. It's a debris. Clear? Dental? Govindji, is it clear? Please do let me know if any doubt is there. You can intervene at any point of time. It's in science and tech. It's my core subject. You can ask me anything related to it. Okay. Now we have to discuss what are the risks. What are the risks associated with the space debris? When you talk about the space debris, is there is any risk? The first is your in-orbit risk. The rising number of space debris increases the potential danger to all the space vehicles, especially to ones with human aboard the International Space Station. So first, what is the risk? Suppose this satellite is there. Suppose if you want to park, the first risk associated with this. Okay. First risk associated with this is your, suppose if you want to park the satellite over this region. Suppose if you want to park the satellite in this position. So first of all, you have to track whether you, no doubt we are having the tracking arrangement. You have to track whether the space is available or not, whether the proper inclination is available or not. So that means the cost of operation automatically increases. The cost of operation automatically increases because if the satellite is parked in this position. This is your first cost of operation. Cost of operation. Okay. Now, second is your Caseless syndrome. Now, what is Caseless syndrome? This question is asked in the prelim itself regarding Caseless syndrome. Now suppose you have already seen the density of the satellites. Already have seen the density of the satellite in 2015. How dense it was. Suppose if you want to park the satellite in this position. Now what will happen? This is the satellite. Now this satellite is a space debris because it is of no use. Now what will happen? This satellite will collide with this satellite, and some other satellite will also collide with this satellite, and some other satellite will also collide with this satellite. So because of the presence of junkyard. Okay, we are also going to discuss the junkyard orbit also in way forward. So we are discussing regarding the Caseless syndrome, what it is. Suppose if a satellite is being parked in this position, this is an operational satellite, just we have parked it. Now there is a high possibility that this satellite will collide with this one. This satellite will collide with this satellite. This satellite will collide. Because of the higher collision, this operational satellite will also become a dead satellite. It's of no use. So it is called Caseless syndrome. Because of the presence of huge number of space debris, they are having the potential to collide with this satellite and also damage this satellite. So this satellite is called this process is called Caseless syndrome. This process is called Caseless syndrome, in which the satellite you have launched for the purpose of operation, they are also being damaged. Okay. Is it okay? Okay. Increases cost apart from that interference with the scientific and other observations. Suppose if a satellite is being parked for the purpose of monitoring the topography, or for the purpose of remote sensing satellite, for the purpose of monitoring the resources also, because of the excessive presence of the satellite, it cannot monitor it. So that means it interference with the scientific and other observations. Space debris also disrupts reception of radio telescopes and distorts photograph from the ground-based telescope, affecting the accuracy of scientific result. So because of the presence of excessive number of satellites that is of no use, the data are being disturbed. Okay. Now how to avoid this problem? Strategies to tackle space debris. What are the steps that must be undertaken to control the problem of space debris? The first is your preventive measures. Spacecraft and orbital stages should be designed not to release debris during the normal operation. So first of all, your preventive operation, that means the spacecraft or satellites, they must be designed in such a fashion that it do not release any sort of space debris. It do not release any sort of space debris. Second is your mission should estimate and limit the probability of accidental collision. Okay. The second is your we must park the satellite in such an orbit with such inclination that there is a very less probability of collision with other satellite. बहुत कम chances है ताकि वो किसी और satellites के साथ collide कर सके. So we can say that there is a very less probability for Caseless syndrome. Avoid maneuvers for spacecraft coordination of launch windows and should be considered. Move satellites in higher orbit, particularly move satellites in higher orbits, particularly geostationary orbit, which are too far away from the re-enter. Removal procedure to reduce the number and masses of the object on orbit, reduce the probability and severity of orbit hypervelocity collisions. Following techniques can be considered. Now we have discussed that. Now what are the approaches? The first approach what we have discussed is that the satellite should be parked in such a fashion, such a way that it releases less number of space debris. It should be parked in such orbit with such inclination that it is having very less probability towards Caseless syndrome, or it is having very less probability for the purpose of less probability towards collision. Apart from that, we should also consider that there is a junkyard orbit. The junkyard orbit is basically situated after your geostationary or geosynchronous orbit. Junkyard orbit is this orbit. ठीक है ना? This is your space junkyard orbit. Suppose now if you want to park the satellite, now this satellite it is of no use, so you can park this satellite in junkyard orbit. Okay, so apart from that we can also develop certain satellites that will be responsible for the collection of space debris. Okay, we can also develop certain satellites that will be responsible for your collection of space debris. Like example is your space SIR will make the debris object move closer enough to the upper atmosphere that after release from the tether a spirals and burns up. Laser, this method is used for slowing object using high powered laser fired from that so that they can move out of the orbit. So laser is a technology which is basically used for redirecting the space debris. It can change its inclination, it can change its orbit so that it won't collide with the operational satellite, so that the operational satellite won't become space debris. A space tug is actually a spacecraft that is used to move multiple pieces of debris to disposal orbit in geo. So what is a space tug? See, suppose this is the Earth, this is your low Earth orbit, and this is your low Earth orbit, and okay, so this is your low Earth orbit, this is your low Earth orbit, this is your polar orbit. Now what is space tugs? So space tugs are the satellite, like this is your satellite. A space tug is a satellite, okay, that have the net. This is the net portion, Now what it will do, while moving, it will collect the space debris and take this space debris to the junkyard orbit. Okay, are you getting my point? जिस तरीका से what we are using net for the purpose of catching the fish. So such is your space tugs. Space tugs are basically responsible for collection of all the space debris that is of no use, and it can take those space debris to the junkyard orbit. Is it okay? Clear? चलिए. So this is your removal process. चलिए. Now we have to see what are the global initiative taken in this regard so that we can avoid Caseless syndrome. The first is your global initiative by space agencies to tackle space debris. Mridul ji, dental world, if any doubt please ask. Is it clear? If there is any doubt please do let me know. Global initiative by space agencies to tackle space debris. Interagency Space Debris Coordination Committee, Space Debris Mitigation Guidelines, United Nations Committee on the Peaceful Uses of Outer Space deals with the issue of liability of damage caused by the space. So who will take the responsibility if the space debris will damage the operational satellites? Japan Aerospace Exploration Agency and the European Space Agency have partnered with the startups to help with the removal of space debris. Remove Debris has tested two different technological for removing space debris, capture with the net of or capture with a harpoon. So already we have discussed space trucks. The space trucks are responsible for collection of all the space debris and they will take it to the other orbit. ठीक है? चलिए. Now we are going to discuss the other topic that is called black holes. So any doubt related to space debris you can ask me. Please. Any doubt related to space debris you can ask me. Okay, now we have to discuss regarding the black hole. We are going to discuss complete regarding the black hole. Are you enjoying the topic, Dental, Mridul? Are you comfortable in English? If you will face any difficulties, I can explain it in Hindi too. Okay, now black hole. Black hole at the center of a Milky Way was photographed for the first time. So in the center of the Milky Way, we are having a black hole called Sagittarius A. Okay, na? Suppose this is your Milky Way. At the center, we are having a black hole that is called Sagittarius A black hole. This is your Sagittarius A. Okay, this black hole is called Sagittarius A. Sagittarius A black hole. So it was being photographed for the first time. So we have to discuss what is black hole. Okay. So first of all, what do you understand by black hole? Let me explain you. After that we are going to discuss the black hole on the board itself. Be comfortable. So black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because the matter has been squeezed into a tiny space. This can happen when a star is dying. Our sun will never turn into a black hole because it is not big enough to make a black hole. Because no light can get out, the people cannot see the black hole. So what is black hole? Now we will see completely regarding the black hole. Black hole. Okay. Black holes. Okay. Now what is black hole? So you have already seen that the star during its dying phase, all the masses of the star, they get squeezed to a point called singularity point, and the masses are so much squeezed, and because of that the gravity becomes so strong that even the light cannot come out. Are you getting a point? Even the light cannot come out because the star in its dying stage, all the masses are squeezed to a point called singularity, and because of this the gravity becomes so strong that even the light cannot come out. So you can see the black hole like this is a black hole. This is a black hole. This is a black hole. Now my question is, if this is a black hole, okay? Okay, please do let me know. I have already stated in the beginning itself the gravity of black hole is so strong that even the light cannot come out. Now my question to you guys is, if the light cannot come out, then how we can detect the black hole? You must be knowing that optical telescopes are being utilized for the purpose of detection of a star. Now optical means light. So those optical telescopes are basically responsible for detecting something with the help of the reflected ray. with the help of the reflected ray they are going to detect. So if black hole cannot emit light, if the black hole, because all the light, if it enters the black hole, it cannot come out. So if black hole fails to emit the light, then how we can detect it? Bataiye, how we can detect it? Any idea? Dental, Mridul, can you explain, please? Any idea? Please do let me know. Dental, Mridul, please do let me know. If black hole fails to emit light, then how we can detect the position of a black hole? How we can detect that this is the black hole? Please do let me know. With respect to, okay, no, it's not like that. First of all, the property of black hole is, write it, the star during the dying stage, remember the star during its dying stage, squeezed all masses. The star during its dying stage, all the masses are squeezed to a point. All masses are squeezed to a singularity point. Okay, to a singularity point. Now, because of this, the gravity is so strong. That the light cannot come out. Because of this, gravity is so strong. That light cannot come out. The light cannot come out. Okay, light cannot come out. Now you can see that this is the black hole, and the surrounding area is called event horizon. Remember, this area is called event horizon. Okay, event horizon. This area is called event horizon. Event horizon. Okay, this area is called event horizon, and this is called accretion disk. Now I will explain you. Now the most important theme is, since you have quite understood that black hole fails to emit light, now the question in front of you is, if it fails to emit light, then how we can detect the presence of a black hole? Okay, so suppose it is having higher gravity. Suppose this is another star. Suppose this is another star, but it comes under the influence of this black hole, and because of higher gravity, this will try to pull this star. But one thing you must remember, that in universe, everything rotates and revolves. So first of all, it will enter this. First of all, it will enter the accretion disk, and it will start rotating and revolving. It will start rotating and revolving. And finally, this is the last round towards the space hole. Finally, it will merge into the black hole. Okay, so this is how. But you must be knowing that if this star, when it enters into the influence zone of black hole, it will radiate energy. It will radiate energy. Okay, so this is the energy radiated by the star when it enters into the black hole. Energy radiated by the star when it comes under the influence of black hole, when it comes under the influence of black holes. Okay, so this particular energy that is being emitted or that is being radiated when the stars falls under the black hole, when the star is revolving around the black hole and finally it merges with the black hole, this particular radiation is called a Stephen Hawking radiation. ठीक है, this is called Hawking radiation. This is called Hawking radiation. And remember, optical telescope basically observe this Hawking radiation for the detection of black hole. Optical telescope basically uses this Hawking radiation for the detection of black hole, for the detection of black holes. Is it clear, Mridul, Dental ji? Is it clear? And this is the last ring in the sense the star that is rotating and revolving and it has to finally merge with the black hole. The last revolution that it has carried out in the black hole is called your photon ring. So this is the last ring. This is called your photon ring. This is your photon ring. Is it okay? So this is all about the black hole. Now please do let me know if there is any doubt. Is it clear, Medul, Dental? So in this simple diagram I have tried to inculcate all the things regarding the black hole. We have discussed what is black hole, what is the property of black hole. Apart from that, we have discussed the different nomenclature of black hole like event horizon, accretion disk. Apart from that, how means if the black hole is not emitting light, then how we can detect the black hole? It can be detected with the help of Hawking radiation. And apart from that, we have discussed the photon ring too. Is it clear? Is it clear, please? Okay? Any doubt? Okay, चलो ठीक है. Already we have discussed what is black hole. Now, black holes do not go around in space eating stars, moons, planets. Earth will not fall into a black hole because no black hole is close enough to the solar system. Generally you must know that Earth is not going to get consumed in the black hole because there is no black hole nearest to the Earth. Apart from that, 2020 Nobel Prize in Physics was awarded to Roger Penrose, Reinhard Giesel and Rina Gage for a study associated with the black hole. ठीक है, चलिए. Okay, detection of the black hole we have discussed. Now we will see importance of studying black hole. What is the importance of studying black hole? So first of all, black holes are laboratories for testing fundamental theories that explain how the universe works on the largest and smallest scale. So if you study black holes, there are lot of mystery regarding if you can study black hole, there are a lot of mystery regarding how the universe came into being. Apart from that, we can also study the authenticity towards the Big Bang theory. Enhances the understanding of gravitational forces which can be useful for the global positioning satellite to make them accurate to more than fewer meters. ठीक है ना? Enhances the understanding of gravitational forces which can be useful. That means if we are able to understand regarding the black hole, it is having the potential that we can utilize global positioning system to much accuracy level. Now we have to discuss regarding gravitational waves. Is it clear? Is it clear? Please let me know. Is it clear? Okay. So the next topic is related to laser interferometer gravitational wave observatory, LIGO project. So we are not going to discuss what is LIGO project. Basically, in UPSC mains, the question may be asked regarding the gravitational waves, how we can study the gravitational waves, the property regarding the gravitational waves. So we are going to discuss in this regarding the gravitational wave. But why it was in news? It was in news because Hingoli Revenue Department, Maharashtra, has handed over the land for laser interferometer gravitational wave observatory project for setting up a laboratory along with some other related infrastructure. Is it okay? Now we have to see, in 2016 central government has given approval to LIGO India, a joint India-US detector for research on gravitational wave. So you can see that in 2016 itself the central government has permitted a joint project of India and US government for the purpose of setting up the LIGO observatory so that we can monitor gravitational waves. Now the question is, what are gravitational waves? Now the question is, what are gravitational waves? So you can see that in a space, suppose if I ask you what is my location, suppose if I ask you what is my location, so through latitude and longitude you can determine my location. Okay, if I ask you to place something in a 3-dimensional, then it can be placed in XYZ. Suppose if I ask you what is the position of this, so you have to take XYZ coordinate, X, Y, Z coordinates, XYZ coordinate. Is it okay? चलिए, ठीक है? Okay. So already I've explained, if I ask you to locate my position, latitude, longitude is required, and apart from that, if I ask you to position something in 3 dimensions, the x, y, z coordinate is required. So if I ask you regarding a space, so a space is represented by a space-time continuum. Space जो है, it is being represented by a space-time continuum. Okay, space-time continuum. So space जो होता है, how it is represented? A space is represented in a space-time continuum. Space is represented in a space-time continuum, in a space-time continuum, in a space-time continuum, a space-time continuum. Now we must know what is space-time continuum. So suppose this is the empty space. What we are doing, this is an empty space. So this is a space-time continuum. This is a space-time continuum. This is being represented like this. This is a space-time continuum. A space-time continuum, a space-time continuum, but this is an empty space. Okay, empty space. Now in another case, suppose you all must be using mosquito net. Dental world, Mridulji, are you guys using mosquito net? This is the rainy season, you must be knowing, to prevent yourself from malaria. है ना, dengue, you must be using mosquito net. So think like this is a mosquito net. So if nothing is being kept, over this surface, then it will be like a straight. So in a space, if nothing is there, the space-time continuum appears like this. But if in a space some galaxies, some celestial bodies are there, suppose here this is the celestial body, that is present over here. So here the space-time continuum will be wrapped one. Then here, because of its weight, the space-time continuum will be wrapped one. It will be your wrapped one. Okay, it will be your wrapped one. Okay, ठीक है? So this is the space-time continuum. So this is what, suppose if you kept your pillow over the mosquito net, अगर आप अपने mosquito net पे अगर आप pillow रखते हैं, it will be sagged. So just like that, this is the space-time continuum for the empty space in space, and this is the space-time continuum if some celestial bodies are present. Suppose if I keep the pillow over the mosquito net, it will be sagged condition. Same happens in the space. If certain celestial bodies are present, then a space-time continuum will be a sagged one. ठीक है? Now we have to discuss what is gravitational waves. Okay? So are you guys understood regarding space-time continuum? What is space-time continuum? Is it clear? Please do let me know. Is it clear? Is it clear? Okay. So now we have to discuss what is gravitational waves. What is gravitational waves? Apart from that, we have to discuss regarding the important properties of gravitational waves. So we will discuss what is gravitational waves. Now we will discuss what is gravitational waves. Gravitational waves. Gravitational waves. Okay. So first of all, we should go through the bookish language so that you guys are comfortable with the bookish word. So what is gravitational waves? These are the ripple in space-time traveling at the speed of light caused by some of the most violent and energetic processes in the universe. They carry with them information about the cataclysmic origin as well as the invaluable clues of nature of gravity itself. They are created when objects move at a very high acceleration, a star explodes asymmetrically, two big stars orbit each other, two black holes orbit each other and merge. So what is gravitational waves? This is your space-time continuum. Now if this space-time continuum is being disturbed, now you consider this space-time continuum is disturbed. Now this space-time continuum is disturbed. What will happen? Now if suppose this space-time continuum is being disturbed, what will happen? First of all, how it will get disturbed? One, when two black holes will merge. Two black holes will merge. Second, a star merges with the black hole. Stars merges with the black hole, star merges with the black hole. Third, when two stars are accelerating at a very high speed, when two stars are accelerating at a very high speed, higher speed, at a very higher speed. Okay, now what will happen? Because of the merging of two black holes, because of the merging of two black holes, suppose this is the black hole, because of this merging of this black hole, and because of this merging of this black hole, what will happen? The space-time continuum will get disturbed and it will produce ripples, and these ripples will produce, and this ripples will produce. This ripples is called gravitational waves. This ripples is called gravitational waves. When a space-time continuum is being disturbed because of the merging of two black holes, or because when a star merges with the black holes, or because the two stars are accelerating at a very higher speed, so this space-time continuum will get disturbed and it will produce ripples. जिस तरीका से आप एक शांत पानी में पत्थर फेंकते हैं तो वहां से क्या फिर तरंगे निकलती हैं, वहां से फिर एक वेव्स निकलता है, उसी प्रकार से आप स्पेस टाइम कंटिन्यूम में अगर वहां पे दो ब्लैक होल्स मर्ज कर जाएंगे, या फिर एक बड़ा स्टार ब्लैक होल्स के साथ मर्ज कर जाएगा, या फिर दो स्टार जो है इफ दे आर एक्सीलरेटिंग एट ए वेरी हायर स्पीड, तो यहाँ पे क्या होगा? दिस ग्रेविटेशनल वेव्स आर प्रोड्यूस, दिस ग्रेविटेशनल वेव्स आर प्रोड्यूस. ठीक है ना, ग्रेविटेशनल वेव्स आर प्रोड्यूस, ग्रेविटेशनल waves are produced. Okay, now you have to know certain properties regarding the game. You have to know certain properties associated with the gravitational wave. So when you discuss regarding the property, the most important property that is twice being asked in your UPSC prelims examination is, first is your property, gravitational waves moves with the speed of light. What? Gravitational waves moves with the speed of light. So it moves, gravitational waves moves with the speed of light. Gravitational waves moves with the speed of light. Is it clear? First thing, so gravitational waves moves with the speed of light. Second thing, you might be knowing if gravitational waves is moving with the speed of light. Already we have stated that during the Big Bang theory, all the particles that were being released after inflation, they were moving at the speed of light. But if everything moves with the speed of light, then universe cannot be developed, because if something is moving at the speed of light, then masses won't be there. If masses won't be there, then how gravitational attraction will develop and how universe will come into being? So ultimately they have to pass through the Higgs field, and when they pass through the Higgs field, their velocity reduces and their mass gained. So here the concept is gravitational waves moves with the speed of light. That means it has not interacted with the Higgs field. So first, the second concept is here, less interaction with the Higgs field, less interaction with Higgs field, with Higgs field, less interaction with, no doubt it will have some interaction, but less interaction with Higgs field. Third is your what? It is very difficult to get detected, because it generally do not interact with anything. It is very difficult to get detected. Gravitational waves is very difficult to get detected. Gravitational wave is very difficult to get detected because its interaction is very less, because its interaction is very less. Interaction is very less. Okay, is it clear? ओके गुरुदेव, इसका इफेक्ट इलेक्ट्रोमैग्नेटिक में कैसे होता है हम लोग उसको डिस्कस करेंगे. वी आर गोइंग टू डिस्कस इट. ओके, so gravitational wave will be very difficult to get detected because of its because interaction is very less. So you have seen that since it is moving with the speed of light, apart from that it has very less interaction with the Higgs field, and finally we have seen that it is very difficult to get detected because its because the interaction is very less. So you can assume that if those black holes, we can consider those black holes that were existing during the time of black holes. You can assume that we can consider those black holes that were existing during the time of Big Bang theory. They must have radiated certain gravitational waves, and those gravitational waves are still traveling with the speed of light, and they carry the information regarding the formation of universe. If those gravitational waves are being detected, then we can solve the mystery regarding the origin of universe. So the important theme is here, if gravitational waves are being studied properly, the mystery regarding the origin of universe can be resolved. So if gravitational waves are being detected, then the mystery regarding the origin of universe can be resolved. Then the mystery regarding the origin of universe can be resolved. Okay, is it okay? Is it clear? Mridul, Dental, is it clear to everyone regarding what is gravitational waves? Clear है? Yes. So basically you can see this is your gravitational waves. This is your, what we have discussed, this is your space-time continuum, and apart from that, the ripples that is being generated, is nothing but your gravitational waves. Okay. So already we have discussed regarding significance of detection of gravitational. What is the significance? What is the significance when you can detect the gravitational waves? The significance information that gravitational waves can provide, first is what? This is of much more important, because when you will analyze the UPSC previous year question, you will see that first type of questions are being asked. So information that gravitational waves can provide, first is your gravitational wave will provide a test of Einstein theory of general relativity under extreme condition of gravity where it has never before been tested. They will also give more information about the unimaginably dense form of matter that makes up the neutron stars. Gravitational waves will also tell about how many objects like black holes, neutron stars exist in the universe. This is much important. Generally, one of the important aspects is what? When you will study gravitational waves, it may be possible that we are going to resolve regarding the mystery of origin of universe, whether the Big Bang theory is exact or it's an hypothetical. It can be proved. They will give us insight into what happens during some of the universe most violent explosion. So suppose already we have discussed that the formation of gravitational wave is through when space-time continuum is being disturbed. The space-time continuum is being disturbed. Okay, clear? Now the next topic is your net neutrality. Any doubt, friends? Big Bang theory is hypothetical in nature, but if we are able to study regarding gravitational waves, we can actually authenticate whether it is hypothetical, whether it is false, or whether it is exact. That's why so much of money is being invested regarding the development of LIGO observatory. Clear? Is it clear? Okay, any doubt? If there is any doubt, please do let me know. If there is any doubt till here, we are here, we can address your doubt. Please do let me know. So I would like to end my session. Tomorrow we'll continue the same session. Tomorrow we'll start with the net neutrality. So if any doubt is there, please when the video is submitted, you can comment over, you can comment regarding any doubt. So thank you, thanks a lot everyone. Jai Hind, Jai Bharat.